Okay, so algebra. So quite a lot of this will already have been covered in previous lectures and also in the tutorial sheets that you've been working through. Okay, so this is really to give you a bit of a recap and set you up for some of the next couple of lectures, which will be on kind of harder type of equations. Okay, so what is algebra? I mean, this is stuff we've already been through already. So we're basically just replacing numbers with letters. I should be saying that. We're putting letters in, and we're using those and manipulating equations to basically to turn those equations into things that are useful for us. Okay. And again, the key is practicing in terms of, so there's lots of tutorial exercises, there's stuff on Khan Academy, there's stuff in the textbook, there are other books, so do practice these things, okay? So, so this is just the topics we'll be going through. So, evaluating, basically is just plugging the numbers in. Simplifying them is basically just rearranging equations. So all these things, factorization, transposing, I mean, they're just terms we use for moving things around. I mean, the very simplest example was here, when we had force equals mass times the acceleration due to gravity. All we've done here is we've transposed that formula, we've just rearranged it to find mass. Okay, we've divided both sides by g to give us force divided by gravity equals mass. Okay, very simply that's what we're doing. Okay, it will get harder than that, but okay. So this is another really simple example. Area equals length times width. We're just rearranging some of those symbols to get the thing that we want. Okay. This is once again just going over stuff from the previous lecture. So we've got this thing called exponents and the base. So we've got a number, and the exponent is how many times we're timesing the number x by itself. And it doesn't have to be a whole number. It doesn't have to be a positive number. And I guess you've kind of, I mean, these are basically rules that you should know. So very simply, recapping, if you've got x raised to the power of something times x raised to the power of something else, if you're timesing those x's together, you add the exponents. If you're dividing them, you subtract the exponents, and if you're raising an exponent to another exponent, you times the exponents together. Okay, that's stuff we've just been going through. That's fairly simple stuff. So let's see if I've got a the Khan Academy causes this to fail massively. So not the Khan Academy, idiot. Top Hat. So I guess if we could just quickly do as an example, this guy here. I mean, can you kind of work out what the answer to that is? So just 9x squared divided by x to the power of 3. I mean, how do we simplify that? So I guess if you guys do that. You've got, like, let's say 20 seconds to do that. I'll pick somebody. The board rubber of victimization. Okay. Oh, what a shot. What's the answer? What's the most simplest way that you can write that out? 9 over 2x. 2x squared divided by x cubed is, we cancel out those terms. So that's the same as writing x times x over x times x times x. Okay, if we cancel those out, we just have 1 over x. Yeah. Yeah? So that would be x to the minus 1. Yeah, okay, fine. Let's just take your word for that. So 9 over 2, or you could write 4.5 x to the minus 1, or 4.5 over x. They're all the same thing, okay? or 9 over 2x. Okay, all of these things mean the same thing. They've just slightly simplified that example up there. Okay, so has that confused many people? Okay. So the next kind of thing to think about is that when you're timesing things together, okay, it doesn't matter which order you times them together in. Okay, so in this example here, A times B times C, that's the same as B times A times C. So, I mean, another example here would be 9 divided by 2x. That's the same as 9 divided by x times 2. So that's 9 divided by x times 2. It's the same, super same, yeah? That's a times there, not a plus. If it was a plus, that would be a whole world of pain. And when we're timesing numbers together, or in fact dividing numbers together, it makes a difference whether you're timesing together positive. So like if you times together two positive numbers, you'll always end up with a positive number. So 2 plus 2 times plus 2 is always going to be 4. Okay? But if you times one of those numbers is a negative number, your answer will be negative. Likewise, it doesn't matter which way round you times them, so minus 2 times 2 will always be minus 4, whereas 2 times minus 2 is also minus 4. Okay, it doesn't matter which way around you do stuff. If you've just got one minus in there, if you've got an odd number of minuses in your multiplication or division series, then the answer will be negative. If you've got an even number of minuses, because if you have a negative times a negative, you will get a positive. So minus 2 times minus 2 is plus 4. Okay? So it's important to remember that if you've got basically an odd number of minuses, you'll always end up with a minus, and that's just, okay? So this is something that you need to watch out for. Quite often catches you out. So let's have, so what I want you to do is, for this example, to just look at these two expressions. Okay, so this one, minus x squared times y, all times x times y squared. Okay? Is that the same or different to this guy over here? Okay? So what I want you to do is, so the way to answer this question is to try and multiply out all of these terms. Okay? Multiply out all of these terms. Okay? And then see if you can, if they are the same. Okay, so can you simplify this into that, or simplify that into that? Okay, so I'm going to see if I can do this. It's quite hard. I often mess up. What I got? Minus x squared times y times x. X3. Yeah, so looking at my working, do you think that'll help? Might be a good idea, might be a good idea, I might get things wrong, never know. Can you guys actually see over here what I've done? Or am I too much of an angle for you?
Kind of, depends a little bit like what.
Okay, how much you care and all that kind of stuff.
Right.
Okay, so we're going to stop there. Okay, we'll just have a quick show of hands. Okay, so everyone put both hands up. Okay, so take your hands down if you think they're the same. Okay, take your hands down if you think they're different. Okay, a lot of peer pressure going on there in terms of, oh, let's go with the crowd. So you could do that all blindfolded, but then you risk me just walking out and seeing that. But yeah, so I think they're different. Okay, so if we start to multiply these things out, okay, because we've got no pluses in here, we can kind of ignore these brackets. Okay, so because it doesn't matter what order you times things together, we're just timesing all of that. So minus x squared, okay? So we're not timesing minus x by itself twice. We're timesing x by itself and then timesing that essentially by minus 1. Okay? And that's the key to getting this right. Okay? So x times itself times minus 1 times y times x times y times y. So we've got 3 y's times each other, so that's y cubed. And we've got 3 x's times each other, okay, times minus 1. So that'd be minus x cubed. Okay? And then on this side, we do the same kind of thing. So we've got how many x's? We've got 3 x's, okay? And we've got, but if we look at this bit here, we've now got minus y squared. So that's the same as saying minus 1 times y all squared. Okay? Minus 1 times minus 1 is what? 1. Yeah, plus 1. Okay, so in this case it would be plus 1 times y. So plus 1 times y is the same as y, but we just put that plus 1 in there to help us kind of like go through the whole understanding process. So in this case it will be plus 1 times y times y times y. So this one will be x cubed times y cubed, whereas this side will be minus x cubed times y cubed. Okay? So they're subtly different. Okay? And the way that we can tell is by kind of manipulating that formula and kind of like simplifying. See if we can turn one into the other. In this case, we can't. Let's just get all these things down here. So this is just to reiterate this issue about when you're substituting numbers into these formula at the top, and you're multiplying out values where you've got, in the case of this top one here, something minus x squared. Okay, that's different. Okay, so when you're substituting in a number into that, it matters whether you consider the minus part of the squared bit or not. Okay, so that's where most people get this wrong. So if you just look at the bottom line on this, okay, so if we wanted to evaluate y equals minus x squared, okay, quite a simple equation. Let's say we want to put into that, okay, if we knew what the value x was, we wanted to work out the y, and if it was 5, okay, so if when you substitute that 5 in, okay, it makes it kind of, it's a bit tedious, but when you do plug numbers into these equations, if you kind of rigorously put these brackets around just the value of the letter, okay, not including the sign either side, okay. So in this case, putting in the number 5 in brackets, so we just put brackets around just the x, substitute the 5 in, minus 5 squared, okay, is minus 25, okay? But if we had substituted, if we'd have just put in if we'd have just written the 5 in there instead of the x, okay, it would be minus 5 squared. And minus 5 squared is 25, because minus 5 times minus 5 is positive number is 25. So do this. Okay, when you're evaluating these expressions, okay, put in brackets around the letters that you're substituting the numbers in for, then put the number in. Okay, I'm getting some confused faces for this. So let's do this example. Okay, so for I think it's the first one. Let's just do it. Okay, so the first one, 2x cubed minus x squared plus y. Okay, so just write that down, and then substitute in the numbers minus 3 and 2. Okay, and then work out what the answer is. 2x cubed minus x squared plus y for x equals, what was it, minus 2, and y equals something 9. Okay? So do it by putting brackets in, so 2 brackets minus 2 cubed minus 2 squared plus 9. Put brackets in like that, equals something. And then do it without putting brackets, so 2 times minus 2 cubed plus minus 2 squared plus 9. Okay? These are supposed to be different. I can't make a mistake. Minus a 2. Yeah, there we go. So hopefully you didn't make the same mistake. Well, you did make the same mistake that I did. So if you look at if you substitute in using brackets. So for this is the equation that we're trying to substitute in. If you put brackets in here, 2 times minus 2 all cubed. Okay, so minus 2 all cubed. So that's minus 2 times minus 2 times minus 2. Okay, so we've got an odd number of minuses in there. Yeah? So it will be minus 8. Okay? So 2 times minus 8 is minus 16. Okay? And then 2 minus are minus 2. So in this case, we take minus 2 squared, which would be 4. So this would be minus 4. Yeah? Okay, so minus 16 minus 4 plus 9, we should get the answer, which is minus 11, which is the correct answer. Okay? Now, if we hadn't have put those brackets there, okay, if we'd have, been a bit slapdash, we just put the numbers in, we've done this, okay? So we substitute in 2 minus 2 cubed. So 2 cubed is 8, yeah? So minus 8 is still 8, so 2 times minus 8 is minus 16. That part of the equation is fine. Doesn't matter if we put the brackets in or not, okay? But if you go to this bit here, minus 2 squared, okay? What's 2 squared? 4, yeah? What's minus something? So if you minus, it's a plus, okay? So this would then become plus 4. So instead of having minus 16 minus 4, we've got minus 16 plus 4, and we end up with a completely different answer. Okay? So if you didn't follow that, go through that this evening, tomorrow, in your own time. Is that a kind of
Where did you get your negative 2's for? Because it's negative 3 in the question. And it's y is 2.
Yeah, okay, that's that.
Yeah.
Idiots! Okay, so I've made a classic error, is I've taken this equation and then I've used these numbers. That's a good spot. Did that confuse everyone else? Yeah. Retard! It doesn't matter in terms of the thing that I was trying to teach you, in terms of, it doesn't matter what these actual numbers are. Okay? Whether it's a 3 or something, we could change these to a, what are they supposed to be? A 3, that's supposed to be a 3, that's supposed to be a 3, that's a 3, that's a 3, it's a 2, it's a 2. This will always be the same whether you put the brackets in or not. So 3 times 3 times 3, 20, no, something, yeah? And that's always going to be minus 50 something. 2 times minus 27, so minus 54, right? But this, okay, this time minus 3 squared is going to be 9, okay, plus 9, so minus plus 9 is minus 9, whereas this time minus 9, the minus will turn to a plus, and this will be plus 9, okay? That doesn't make much sense the way I just blurted it out so rushed, but the important thing is that it makes a difference whether you put these brackets in when you substitute the numbers, okay? Because it then makes a difference whether you're squaring or you're using the exponent on the symbol before the number, okay, as well as the number itself, okay? Hopefully this will be obvious. So when we did before timesing two positive numbers together, or timesing a positive and a negative number, works exactly the same for divisions. Okay, I'm not going to go through that. You can work out those answers in your own time. And so I just want to go through now some of these things about when we've got kind of a more complex equation, okay, how we go about some of this transposing or rearranging these equations, okay? And basically the kind of the what you want to try and aim to do is figure out how to simplify something that looks a little bit more complex into something that's a little bit more easy. And the most simple example at the top there, 7a plus 3a, okay, because if you're looking at just the same thing, so variable a and another lot of variable a, so you've got 7 lots of a, so 7 apples, and you've got 3 lots of the same other thing, because you're just adding one lot of the same thing to the other thing, you just add the two amounts of that thing together. So in this case, you would have 10a. So you can simplify 7a plus 3a into 10a. Super simple. Similarly, if you've got variables squared, so p squared or a squared, it's the same. You can add those variables together. Okay, so 8p minus 1.5p, you're just adding those, so p squared, you're just adding them together. You can only do this when this whole thing, this p squared, is the same between all the things you're adding together. Okay? So in the case here, you've got 7a and 3b. Okay, you can't add those together, okay, to be 10ab. Okay? Because you're not adding things that are the same. Okay? Okay, so I mean, if these were apples and bananas, right? If you had 7 apples and 3 bananas, you added them together, you'd have 10 of something, but you wouldn't have 10 of this new bizarre combination fruit, apple banana, right? Okay? They're separate, discrete things. Okay? Just some quick examples here of let's jump to this last one. Okay, so just looking at that last one, see if you can simplify that equation. Okay, just by some of those rules we've got. My victimising sponge back. Right. Heads up. Right. No, you caught it. So what's the answer? What's the simplest way of writing down this bottom guy at the bottom here?
8ab plus 2c.
Yeah, exactly. That's great. So you can because AB and BA, because they're just times together, it doesn't matter which order you put those in, that's the same thing. Okay? So we can add those two together, but we can't add in this third guy because that's he's not in the same group. Okay? So similarly for this guy here, 5x and 23x, okay? Those are the same thing. Okay? So we can simplify those. We can't, even though this is still an x here, because it's x squared, we can't add that guy in. Okay? So that would just become something else. That would become 28x. I'll teach maths, 28x minus 3x squared. Okay? So hopefully that all made sense. Okay, so we're going to go on now and look at other ways that we can simplify these equations. Okay? So just some kind of terminology. Numerator on the top, denominator on the bottom. Okay, so simplifying isn't just about adding common terms together. So that's the terminology for what we've just done is called grouping common terms. So we've found things in the equation that are the same, we've just added them together. Okay? So we can also identify common factors. Okay? And you can only group together common factors. So common factor is something when you can you divide the number by that thing? Okay, so in this case, can you divide x? Can you divide x squared plus y? Can you divide that by x? Okay, and you can't. Okay, so because this has got a y in it, you can't simplify that any further. Okay, if it was just x squared divided by x, okay, you can see that there's a common factor in both of those things. X divides by x one time, and the top divides by, and x squared divides by x twice. Okay, so we could divide both the top and the bottom by x. Okay, but we can't do that in this case. Okay, so in this case, we want to look at this. Let's look at this first one here. So 3 divided by 6x minus plus 18y. Okay, can we find any things in that that we can kind of divide everything by? Okay. So we can, if you want to think about it. So 3 can be divided by 3 once. Okay. 6x can be divided by 3. Okay. So it doesn't matter what the value of x is, because it's times by something 6 times. Okay. There must be some number of them that you can divide by 3, because 6 is divisible by 3. Similarly, 18, okay, is divisible by 3, 6 times. So we could rewrite that equation. That is the same as saying 1 divided by 2x plus 6y. Okay, it's the same. If we timesed 1 divided by 1 divided by 2x, if we got 1 divided by 2x plus 6y, if we timesed everything in that equation by 3, we would get that one up there. So 3 is a common factor in everything in that equation. Okay? Okay, we can do that with equations like this. Second one, so in this case, the common factor doesn't have to be a number. Okay? It doesn't even have to be an algebraic variable. It could be like a group of algebraic things. Okay? So in this case, basically the number x minus 3 appears in this equation. The top can be divided by x minus 3, because this is basically 2 times x minus 3. So if we divided that by x minus 3, we would just get 2. And on the bottom, we've got x minus 3 times, basically these brackets means we're timesing it by itself. So x minus 3 times x minus 3. And x minus 3 times x minus 3 can be divided by itself. Yeah? So we could simplify this equation to 2 divided by x minus 3. Okay? Similarly, the last one, okay, we're looking at that one. Is there something that we can look at this one? X plus 4 divided by x plus 8. 2x plus 8. Okay? So we're thinking, well, looking at x plus 4, can I rearrange this bottom thing in it so it has some part of it is x plus 4 times another number. Okay? And if you look at that, it's kind of there's an x in it, and there's plus, and there's something that's almost the same. It's like just a factor of 2 out of there. So if we take this bottom bit, okay, we've got a bottom bit of so write the whole thing, x plus 4 divided by 2x plus 8. Okay? Now if we just look at the bottom part and think, actually, can I write that as x plus 4 times something? Okay? And if you look at the x part, if I times x by, if I make that 2, okay? If I multiply this out, 2 times this part of it, and then 2 times that part of it, so 2 times x is 2x, plus 2 times 4, which is 8, okay? So it looks like I can rewrite this like this, okay? Which then gives me that this is then a common factor in the top and the bottom, okay? So I can then rewrite that as x plus 4 divided by x plus 4 times 2. Okay? So we can basically then say, well, if we divide the top by x plus 4 and the bottom by x plus 4, that gives us, there's 1 x plus 4 and an x plus 4 divided by 1 x plus 4 and x plus 4 times 2. So that's the same as writing 1 over 2. Yeah? So 1 times 2, 1, 2 is 2, so it's just the same as writing 1 over 2. Okay? Okay, some more rules now to help you manipulate fractions and stuff. And most of this should have been covered in the tutorial. Okay? So if you've got one fraction times another fraction, it doesn't matter what the top and the bottom of that fraction are. They could be any variables. They don't have to be the same. But if you're timesing one fraction by the other, that's the same as just extending the divide line across the two. Okay? Times the numerators and the denominators together. Okay, so this would simplify to 4x divided by 5y. Okay? This would simplify to AD divided by BC squared AB. Or B squared AC squared. Okay? You just times in the top and the bottom together. When you're dividing, if you were dividing one fraction by another, okay, all you do is you take the number that you're dividing it by, the fraction you're dividing by, you turn that upside down, and you can then considering it as a timesing by. Okay? And that enables you to do the same kind of trick where you just multiply out the top and the bottom, okay, of your fractions. So I think this was mostly covered in some of the tutorial exercises last tutorial round, right? Yeah. Some nodding, some okay. Cool. So these are basically some examples you can go through and try and simplify, but we're kind of running out of time. So